It is like we can say it is kind of a it is a case study about a project that we have finished here at CSIR CSIO. We designed one precision farming system that was IoT capable also. So although your training module is focused on embedded systems and PLDs, but today some of the flavor of IoT also and some of the terms related to IoT. That means when some embedded system is directly connected to the cloud server also through some gateway or through directly through Wi-Fi or any other communication medium which we will discuss. Uh, when your embedded system, your microcontroller is somehow connected to the internet, we can say that, and the control and display is done through the internet, through the cloud, then we can say the system is IoT enabled. So, uh, during the discussion, if you find any of the term which you are not familiar with, kindly ask me. Maybe you can unmute yourself and ask me, because on this home screen I am not able to get your uh, uh, chat response. And after the end of the lecture, at the end of the lecture, I'll surely take all the questions, whatever you will ask in the chat during this course. Okay, so before directly jumping into design of precision farming system, we will first once go ahead and discuss some of the design considerations. That day we have discussed embedded system design considerations on the first day of this short term course. Similarly, if you have to design any embedded system based application which you need to design for any application, for any specific application, then there are few important questions that you need to first discuss amongst your design team. They are few of these questions are indicated in this slide. So what are the physical signals that need to be measured? That means what are the parameters which you need to record, which you need to measure? Okay. Then how frequently we need to collect signal and how fast the data should be exchanged over the network. Fine. So this means the sampling rate and then data communication rate. Okay. Should sensor be connected to cloud directly or via gateway device? This means um, all the sensors, there can be two ways of connecting them to the internet, to the cloud. They can directly be connected to the cloud, like each and every sensor can be made IoT capable. That means can be given some internet connection. uh, their microcontroller, whatever microcontroller we are using, it can be connected to some ethernet module or some wireless wi-fi module, or this gsm module, and then we can give the uh, this network to that specific microcontroller and all the sensors connected to that microcontroller. Or there can be another method that through some offline communication methods, just like radio frequency RF transmitter and receiver, you must have heard other Zigbee and Bluetooth, BLE, Bluetooth low energy. Those kind of modules can be used between various different microcontrollers. Uh, uh, so the microcontrollers that are connected to various sensors are called edge computing devices in terms of IoT language. uh, any edge computing device can be like uh, defined as a standalone single unit which measures or takes some physical inputs with some sensors and do some kind of data processing at its end, and then it transmits the data to the cloud. Okay, so this microcontrollers, these all edge devices, uh, can be connected through these kind of offline communication, Bluetooth or Zigbee or radio frequency RF, and the data can from all these microcontrollers, all these edge devices can be collected at a single control unit, which we can say, which we term as gateway. It can be a microcontroller again with somewhat more processing capabilities and more memory to store the data from all the devices which is coming, and then it can be connected, that single device can be connected to a cloud uh, through this internet TCP IP protocols, and then it can transmit and store all the data and display on the mobile application or on the web applications. Fine. So at the end of this presentation, I will show you in our application also whatever free cloud or these kind of networks in IoT, for IoT, whatever we have used. I'll indicate the names also. You can also, along with your students or for their projects, you can also try using these some of the free platforms for trial. So then a next point is how much memory is required. The memory requirement can be calculated from the type of data and uh, from the fact that if the cloud is not connected, the internet connection somehow is disconnected. So how much data you need to store in the device itself, how much data you need to store offline, uh, and accordingly you can calculate the memory. And there can be many more uh, questions, many more decision points, we can say, discussion points, according to, based on your application, your specific application, which you need to consider before starting to design any system. Okay, so now coming to the hardware components of the system. Yeah, hardware design of sensor nodes. Sensor nodes, we have just uh, discussed in the previous slide that the microcontroller which is connected to the sensor, various sensors which are measuring any physical signal, temperature, pressure, any relative humidity, uh, viscosity, any kind of measurement as per your application, um, uh, and some computational platform is connected, like microcontroller or microprocessor or any single board computer, and and it is then connected to uh, some gateway or other microcontrollers through any communication medium, that is called edge computing device, or here we have named it as sensor node. Okay, so a sensor node consists of sensor device, a microcontroller, communication interfaces, power management module like battery charging, discharging, over voltage protection, all these come in power management, and other peripherals as per the requirements. Maybe other peripherals can include any input keyboard, any display unit, any other external memory if required. So all these come under other peripherals. Okay. So first step in hardware designing is the evaluation and selection of an appropriate sensor, considering the following factors. sensor resolution. This determines the smallest measurement that a particular type of sensor can reliably detect. Okay, so resolution, that day also we discussed a bit. It is the smallest change that can be detected, or that can be recorded. Okay, so type of sensor required. um Either digital or analog sensors can be used in the hardware design. Accordingly, if it is digital sensor, then you have to take its input directly according to the communication protocol that which that sensor specific particular sensor follows, and you need to store that data accordingly. You write a code for that storing the data. And if it is analog sensor, then you need to uh, interface that analog sensor output to some ADC, analog to digital converter, and accordingly get the data stored. Okay, if so, if you are using an analog sensor, you must also consider components for signal conditioning and signal processing in your design. In such cases, the sensor circuit will also have to include either ADC or sigma delta modulator. Okay. The sensor nodes within a network are expected to transmit 8 to 16 decimals of data in 1 millionth of the second. That means uh, in milliseconds, the data transfer should get completed. Okay, and choosing a sensor with required data throughput is essential for efficient operations. So accordingly, you have to decide and choose the sensor. Out of all the sensors available, you have to choose a sensor according to your application and the requirement of data transmission speed. Okay. Then, after sensor microcontrollers, the selection of industrial grade microcontroller is done after a careful evaluation of the business requirement, time and cost of project design, and functional factors. So, what does this mean? Industry. Do you know that? Uh, uh, have you come across these terms? Consumer grade, industrial grade, and military grade, mil grade components. There, in the electronic hardware design and development, there are these three standards most commonly referred to as. All these ICs, resistors, capacitors, which we purchase from the open local market, are of the consumer grade. There are various differences. Uh, consumer grade components are the lowest in the cost, uh, and they have very little, like we can say that the temperature and humidity and other weather parameters if change, then their response also, these components, uh, their output also changes, varies, and their output also varies, and they can uh, stop functioning also. That means they can go out of order also. They can burn or something like that. Like their operating temperature range will be only from plus 10 degrees Celsius to 30, 30, 40, 45 degrees Celsius maximum. But for in the industrial grade microcontrollers, uh, that operating temperature range increases. It can vary from minus 20 degrees Celsius to plus 85 degrees Celsius also. And all military grade also has even the somewhat more better range, minus 30 degree, minus 40 degrees Celsius to plus 115, 120 degree also. And there are there are many other subdivisions, subcategories inside these grades. So it can the values can vary. And one more point is that uh, The military grade kind of devices or components are very much stable in case of high frequency vibrations and other kind of disturbances also, because they may military grade mil grade applications include the devices to be used on the various this auto or this we can say aeronautical applications, various satellite launching things, and other kind of these applications where huge blast or thrust or these uh, high frequency these vibrations will be encountered. So all these components are tested rigorously for different vibrations up to, like in terms of G, if we discuss in terms of G, that is acceleration due to gravity, up to 10 G, up to 100 G also these components are tested. There are very specific test equipments. There are different type of tables and platforms which are actually used to give this kind of frequency to test all these devices. Okay, so selection uh, of industrial grade microcontroller, why it is required mostly in these type of practical application, because the consumer grade uh, components can be used properly only for the hobby kind of applications or very small applications. But when you have to install some device in the like outdoor environments or in the industrial environment where there are chemicals, corrosions, or any other high temperature thing, then you need to select the industrial grade components. So and other functional factors uh, we that include algorithms, security, power consumption, communication interfaces, power management. I think the last is not visible. One second. Okay, the last line is not properly. Coming to the first point, algorithms. The microcontroller use certain algorithms like random number generation algorithm to process sensor data into analog or digital format. So you need to evaluate the algorithm supported by the particular microcontroller before choosing it. Security. Using a microcontroller with built-in hardware crypto engines, that means to stop the various virus and phishing attacks, there are hardware crypto engines also which are much more reliable than the software based this antiviruses and all, such as data encryption standards, DIS, and advanced encryption standard AES engine helps to ensure a secure transmission of data from sensor node to the IoT network. Then power consumption. Using low power microcontroller help in optimizing the overall power consumption, such as there are various examples. So Texas Instruments produce like design the MSP 430 and CC 2650 wireless microcontroller. So a wireless microcontroller means it has uh, built-in Bluetooth and Wi-Fi capability also. So communication interfaces. Most of the IoT application require sensors that use low power wireless communication modems like narrow band IoT, NB-IoT, LoRa, 4G LTE, Cat M1 for communication. So and then if you require certain kind of communication, you should first check that whether your microcontroller which you are selecting has that specific communication interface already inbuilt. Then you can select that microcontroller. The sensor nodes are designed to last for years. once if we install these sensor nodes, uh, some of the applications, some people have achieved up to 10 years of battery life. Once you plug in, and then up to 10 years that battery will work. Uh, so less power consumption is there in the IoT modules, and very efficient batteries are used. And this depends upon the power source of the sensor nodes. One can choose low power batteries, such as this name, lithium ion coin cell battery, as it outputs a constant voltage, is low cost, and offers a battery life of greater than 10 years. Additionally, one may integrate nano timers such as TPL5110 to optimize the power consumption, as the sensor nodes switch between wake up and sleep modes. So these nano timers, this only timer part will work whenever the sensors are not in use. The data, we don't need to capture the data. Then all the sensors will go to the sleep mode. The microcontroller also will use very less, only one interrupt will be active, that will only be from the nano timer, and at this particular time, uh, with this interrupt, the microcontroller will go to the wake up mode and will start functioning. Okay. Now coming to the actual topic of the day, mm, design of precision farming system. So why is it required? The shrinking agricultural land holdings, that means the land which a particular person has is getting reduced due to various factors. Families are increasing due to some other debts or something like that. Land holdings are getting reduced, um, majorly due to the population rise, and unpredictable weather conditions, along with plateaued agricultural factor productivity, uh, posing serious threat for food security, and due to increase of high increase of population. Also, the need of the hour is to consistently increase agricultural productivity levels and introduce smart agriculture as a second green revolution. So this should be like, we should keep in view that it should be a win-win situation for farmers and consumers. This means the productivity should get increased, uh, and the inputs should get the input values cost should get reduced because of the uh, optimized requirements. Like right now, farmers may put more fertilizers or water irrigation than required. If we can uh, if we can make farmers empowered using the various smart agricultural practices on the mass level, then uh, mm, their input cost may get reduced drastically, and still giving better this productivity, and so the farmer will also be ready and be happy to adapt these technologies. So first of all, we should take in confidence the farmers also. Uh, then drones can help farmers to optimize the use of inputs, seed, fertilizer, water, to react more quickly to various threats such as weeds, pests, fungi, to save time, crop scouting, validate treatment, yeah, action taken, to improve variable rate prescriptions in real time, and estimate yield from a field. So, what does this mean? Like, let us say if in a like group of some 5 to 10 villages in one taluk, or one this tehsil, we can say. There can be various different names, mandal or tehsil or taluk, taluka, somewhere it is said. So in those 5 to 10 villages covering around maybe 250 or 300, 500 square kilometer area. uh, if on the subscription basis, we can provide them a drone which is fitted with the that hyper spectral imaging camera, as well as the analysis software. So we can get the drone to fly over all that area in maybe only 4 to 5 days. Complete 5 to 10 villages can be covered, and then accordingly that drone, based on the drone, the images from the hyperspectral camera, we can give a quick analysis to the farmers that okay, your soil is having this malnutrition of um, uh, maybe zinc, or maybe manganese, any other micronutrient, and you need to put somewhat more zinc, but your soil is already having sufficient nitrogen, so you do not need to use urea, uh, you need to use less urea this time. This kind of prescription can be provided to the even the small farmers having very less land holdings, based on the images that drone can capture. So now a single farmer or even a group of 5 to 10 farmers cannot afford this kind of costly equipments, or they, obviously not even a group of 10 farmers would not be able to and would not be willing to also spend 50 to 60 lakhs for such kind of technology, or because they will say that okay, we will spend another 2 to 3,000, 4,000 rupees additional to put all the fertilizers and pesticides unnecessarily also, but we are not capable of spending so many lakhs of rupees. So, but ultimately this practice uh, uh, results in uh, highly uh, uh, they pose a great threat and damage to the health of soil, health of the humans, animals, and water bodies also, wherein those fertilizer will go directly or indirectly through irrigation, through crops, and through the food that we will consume. So these kind of interventions are highly required, wherein farmers do not have to spend huge money. Maybe uh, they will take a prescription service of each and every farmer may have to pay only 500 rupees. If all the farmers of village, as per their land holdings, pay 100 rupees per acre or something like that, so even then the company, if let us say there is some startup who do this kind of who provide this kind of service, can uh, get good return on their investment also, and can help this crop cycle to enhance this kind of enhance the use of less fertilizers, less weedicides, less pesticides, and even still getting good crop yield. Okay, so therefore, the smart agricultural and smart sensing techniques need to be implemented in some sort of subsidized manner, or in the service kind of manner. So the average volume of big data generated and managed by the individual farms will also show a staggering increase between 2017 to 2050. The data generated will also get increased, because the number of data points, the number of sensors will be getting increased. The innovation in agriculture is very much required to keep the farmers aware of the upcoming scientific development, how to reduce the cost of production, use the resources with maximum efficiency, especially the power and water for better productivity. These all we just discussed in the previous slide also. Agriculture 4.0, 4.0, industry 4.0, you might have heard uh, many a times. Industry 4.0 means machine controlling machine. So agriculture 4.0 also refers to something like that only. Marks the fourth coming technological revolution in agricultural sector, which encompasses use of IoT technology for ubiquitous data gathering. Ubiquitous data gathering means all type of data. That means maybe regarding to the water that is being irrigated from, and to the soil, to weather, and to other crop parameters like seed, uh, all the kind of data. Use of always connected farm machineries for variable rate application, use of big data analytics for informed decision making and timely responsiveness. So this was the project that we initiated and under took and then completed last year itself. Uh, the project was named Smart Agri Informatics and Green Internet of Things to enable agriculture 4.0. So, IoT based data acquisition and cloud based data analytics platform for agriculture sector to expedite the adoption of precision farming and agriculture 4.0 in the Indian agricultural sector in affordable manner. So affordability is a key question in this sector because farmers are reluctant to take or use any of such services because they are very costly. So we need to take care of the farmer needs and their like their, we can say, their emotions which are connected to to the money, to the economy. So agriculture sector needs the much needed attention, and 52% population of the country are looking forward to reforms in this sector for increasing productivity, profitability, and sustainability. The most affected section in the whole farmer population is the marginal and small farmers that constitute 84.9% of the total farm holding and with an area of about 44.3%. So majorly in our this country and even in this whole subcontinent, uh, most of the farmers are having very small farm land holdings. So due to the small land holding, their problems are even more. They cannot afford these kind of precision farming techniques and big machineries. So they are dependent on the conventional, completely fully manual ways of uh, agricultural practices only. So for the you must remember that the hardware design of sensor node includes the first step uh, was the evaluation and selection of appropriate sensors. So for this particular uh, application, we used these some of these sensors. So design elements. First design element was sensors. So first of all, we selected this sensor BME 280. Why it was selected? We'll discuss just in the coming slides. Is a combined digital humidity, pressure, and temperature sensor based on proven sensing principles. The sensor module is housed in an extremely compact metal lid LGA package with a footprint of around um, see the footprint 2 2.5 cross 2.5 mm square. Okay, so in this complete uh, this picture, this part is the sensor only this small part with this very tiny hole. This is the sensor part. Rest is the signal conditioning circuit. Uh, its small dimension and its low power consumption allows the implementation in battery-driven devices such as handsets, GPS module, or watches. So this BME 280, or there is another model of this BME 680. These are actually right now being used in one of the very popular company, Fitbit smartwatches. In those smartwatches, this same sensor is being used. So its reliability and this other power consumption and everything is really good, and that is why we selected this sensor. So the BME 280 is registered and performance compatible with the Bosch SensorTech BMP 280 digital pressure sensor. So BME 280 achieves high performance in all applications requiring humidity and pressure measurement. The humidity sensor provides an extremely fast response time for fast context awareness application and high overall accuracy over a wide temperature range. The pressure sensor is an absolute barometric pressure sensor with extremely high accuracy and resolution and drastically lower noise than the older version. Okay, the integrated temperature sensor has been optimized for the lowest noise and highest resolution. Its output is used for temperature compensation of the pressure and humidity sensor and can also be used for estimation of the ambient temperature. BME 280 provides both. Now there are various communication modules, SPI communication, I2C communication. There are SPI buses and I2C buses. So this sensor provides both these interfaces. There are various digital communication modules are there. You must be aware of these. Like there are four wires, these kind of various communication modules. So uh, interfaces and can be supplied using 1.71 to 3.6 volt for the sensor supply and 1.2 to 3.6 volt for the interface supply. Okay. So measurements can be triggered by the host or performed at regular intervals. So either you can control this sensor from an external button or switch or any smart uh, application. So uh, and they can be like uh, uh, we can say that they can be uh, automatically they can be performed at regular intervals, like every 1 second or every uh, at every 100 millisecond one reading will be recorded. So it can be used in both the ways. When the sensor is disabled, current consumption drops to 0.1 microamperes. That means almost nil current consumption is there whenever the sensor is put to like sleep mode. So BME 280 can be operated in three power modes: sleep mode, normal mode, and forced mode. Now, coming to the next sensor that we have used for this particular application for designing the precision agricultural system, it was Aerometer. Aerometer is a company, Watermark 200 SS. So watermark sensor is a resistive device that responds to changes in soil moisture. So this is soil moisture sensor. Once planted in the soil, it exchanges water with the surrounding soil, thus staying in equilibrium with it. So, okay, I'll just show in the next slide what actually happens, how this sensor works. Soil water is an electrical conductor, thereby providing a relative indication of the soil moisture status. As the soil dries, water is removed from the sensor and the resistance measurement increases. Conversely, when the soil is rewetted, the resistance lowers. The watermark sensor is unique in the way that it takes its resistive measurement within a defined and consistent internal matrix material rather than using a surrounding soil as the measurement medium. So the sensor actually, in this case, the sensor actually is not touching the soil. So it has one kind of cloth, you can say a porous cloth or foam, some material surrounded uh, around the sensor, and it this porous material gets wet when dipped in the soil, and this sensor reads the actually the resistance of the sensor changes according to the water content in that cloth, in that material. So this unique feature allows the sensor to have a stable and consistent calibration that does not need to be established for every installation. So the watermark sensor consists of a stainless steel electrodes embedded in a defined and consistent internal granular matrix material that acts as a soil in the way it moves water. That means this material actually is uh, act, is acting as a dummy soil, just in the way that water moves from this material. That means when this part of the sensor, this is dipped inside the soil, if the soil around this material is wet, so the water will be transferred to this white portion, and according to the moisture of this white portion, this material, uh, the the sensor which is placed inside this, uh, the resistance of that sensor will be changed. This matrix is encased in the hydrophilic material that establishes good hydraulic conductivity with the surrounding soil and is held in place by a durable stainless steel perforated shell with plastic end caps. So hydrophilic material, it helps in attracting the water, the moisture. So, and then the outermost part is this stainless steel mesh. Okay, so it some of the features, it has proven stable calibration, a range of measurement from 0 to 239 uh, centibar or kilopascal, uh, fully solid state, will not dissolve in soil, not affected by freezing temperature, internally compensated for commonly found salinity levels. Like there are various soil is saline due to the presence of various salts, various minerals. So it is already compensated or calibrated for commonly found salinity levels. Inexpensive, easy to install and use, compatible with AC or DC reading devices. There are signal conditioning circuit can be made, with which it can be configured or connected to any of the microcontroller or any other direct display unit also. No maintenance is required once it is installed. It has stable calibration, so no maintenance is required. Next is very common temperature sensor. You must all must have tried to use this. This is like this one. Uh, we use the this one, DS18B20, is a common temperature sensor, very easily available. Why we have used this was due to this shell casing of the temperature sensor which this sensor provides. Although it has somewhat slow time response, but we required this uh, waterproof casing which this sensor provides. Okay, so this was readily available. That is why we use this one. So DS18B20 digital thermometer provides 9-bit to 12 bits. So it DS18B20 provides 9-bit to 12-bit Celsius temperature measurement, direct temperature uh, measurement, and has an alarm function with non-volatile user programmable upper and lower trigger points. That means you can program the sensor to give a specified alarm if the temperature increases beyond some point, or lowers down or decreases beyond some other value also. Let's say you have to measure the room temperature, and you do not want your any air conditioner or heater to heat the room temperature above 30 degrees, and do not want to uh, get the temperature below 20 degrees. So only with the single sensor, inside the sensor only, the alarm functionality is there. So you can configure in such a way. So DS18B20 communicates over a one wire bus that by definition requires only one data line, and the second line is a ground for communication with the central microprocessor. Another very good feature of this thermometer with this temperature sensor is uh, that it can derive power directly from the data line, eliminating the need of an external power supply. And it has a unique 64-bit serial code which allows multiple DS18B20s to function on the same one wire bus. This is a very good feature of this kind of sensor, and some other sensors also which use one wire communication as the their communication bus. So what happens is that with the same single digital uh, bus digital line, you can add up to you can just you have to uh, connect multiple you can connect up to thousands of multiple sensors, like just parallelly you have to connect all the uh, this ground the common ground for all the sensors you have to connect together, and the data line for all the sensor you have to connect together on a single data line. Okay, so then there will be a serial code, 64-bit serial code, unique code for each and every sensor. So on the single line, if you have connected 1,000 or 10,000 sensors, so 10,000 different unique codes will be there. So you can read each and every sensor reading separately along with their code. Like let us say on in the 2 kilometer or 5 kilometer area, you have put various these 10,000 different temperature sensors for some kind of continuous temperature measurement at various different points. So you can name different sensors according to their serial code, their unique code. You can designate that okay, this sensor is placed at the first point, and then second, similarly like this. So geographically, you can mark their locations, and then uh, on the single line only you can get the temperature reading of all those 10,000 locations. Okay, so this is it is simple to use one microprocessor to control many DS18B20 distributed over a large area. So the features are programmable digital temperature sensor, communication using one wire method, operating voltage is 3 to 5 volt, temperature range, the temperature which it can measure is minus 55 degrees Celsius to 125 degrees Celsius with an, it is not a very good accuracy, but for a common general uses, it it is still fine. 0.5 degrees Celsius. Output resolution is 9-bit to 12-bit, which is programmable. So unique 64-bit address enables multiplexing. Conversion time is 750 millisecond at 12-bit, but actually due to this is conversion time which it like uh, while the after the communication which it takes, but due to the time response of the sensor is a bit on the lower side due to this metal housing and all. So actually sensor the order which we study in the control system also gets increased due to whenever we use this housing or well outside a sensor. So otherwise the temperature sensor is first order device, but due to this kind of housing the it becomes a second order device, and accordingly its time response increases somewhat. So available as uh, like in various form factors. As an IC you can purchase, or as a waterproof sensor you can purchase. Okay. So then coming to the after all these sensors attached to some kind of microcontroller and others signal processing circuit. Uh, yeah. So after these sensors are all connected to a microcontroller, and the data is collected from the various sensors at various uh, different points. All these sensors and their microcontrollers are named as sensor nodes or the edge device. So from all these devices, let us say there are 10 different devices placed in the field at 10 different places. So you have to place at very far away locations. So you have to now connect these all devices to one single gateway, which we can say which will take and capture the data, and uh, uh, like it will manage all the data coming from various different sensors, and then manage the data coming from various sensors, and it will and then it will transmit the data to the cloud server. Okay. So LoRa, long range radio, uh, is the short. LoRa is short form for long range it is a RF communication itself, but it is somewhat different than the traditional RF transmitter receiver that we use, in the way that it has its name indicates that it is a communication protocol for to be used over long ranges, and it uses very low power also. It is a spread spectrum modulation technique derived from the chirp spread spectrum CSS technology. Semtex LoRa device and wireless radio frequency technology. LoRa technology is a long range, low power wireless platform that has become the de facto technology for IoT networks worldwide. It is very recently patented in 2000, I think 2014 or 2015, but it has like become a very common commonly used technology. LoRa technology and the Open LoRaWAN protocol enables smart IoT applications that solve some of the biggest challenges facing our planet: energy management, natural resource reduction, pollution control, infrastructure efficiency, disaster prevention, and more. LoRa has like the communication sometimes the range of the communication we can achieve with the LoRa transmitter and receiver can be up to 10 kilometers based on the somewhat more power consumption and the antenna's design. Okay, so it is like very efficient communication protocol. You must try to use LoRa devices for some of your projects and motivate your students to try using this technology also. The devices are easily available and not much costly also. It is a new wireless protocol designed specifically for long range, low power communication. LoRa stands for long range radio and is mainly targeted for machine to machine and IoT networks. This technology will enable public or multi-tenant network to connect a number of applications running on the same network. LoRa Gateway has the ability to handle up to millions of nodes. The signals can span a significant distance, which means that there is less infrastructure required, making constructing a network much cheaper and faster to implement. LoRa also feature an adaptive data rate algorithm to help maximize the node's battery life and network capability. The LoRa protocol includes a number of different layers, including encryption at the same network, application and device level for secure communications. LoRa technology application. LoRa technology has multiple applications, i.e., using smart agriculture, smart cities, smart home and building, smart environment, smart healthcare, smart metering, smart industrial control, smart supply chain and logistics, etc. And it is actually not much costly. So this kind of these devices which we have got in our lab just came for around 400 to 500 rupees. So they can be configured as transmitter or receiver, or even receiver for multiple transmitters also, like for a gateway also. Features: geolocation enables GPS free low power tracking application. Uh, Low cost reduces cost three ways: infrastructure investment, operating expenses, and end node sensors. Low power protocol designed specifically for low power consumption, extending battery lifetime up to 20 years. Long range single base station provide deep penetration in dense urban indoor region, plus connect rural area up to 3 miles away. Embedded end-to-end AES 128 encryption. Uh, Supports millions of messages per base station, ideal for public network operators serving many customers. So it is like as of now it has not been used much, but not that much common. But it has a very large variety of scope and applications. So now, after hardware, coming to the back-end application software for designing precision farming system or any of the IoT or embedded system-based system. So this is first first software first protocol that we have used is MQTT protocol. It stands for Message Queuing Telemetry Transport. So uh, where it is used is when the signal is all communicated from the end nodes, from the sensor nodes to one common gateway through the LoRa. Then in that gateway, when that data is all collected and now we are ready to send the data to the cloud, to the internet, then this protocol is used, MQTT. It stands for Message Queuing Telemetry Transport. In addition, it is designed as a lightweight messaging protocol that uses publish subscribe operations to exchange data between client and the server. Its small size, low power usage, minimized data packet, and ease of implementation makes the protocol ideal for machine to machine or Internet of Things world. Firstly, we will go through the reason why using MQTT, how it practically works with the real life IoT. Then we will go through the broker, the backbone of MQTT. So MQTT components are client. Client here we can say that this is the gateway. Like you can just imagine here there were many sensor node, one sensor node, two sensor node, three, four, five. These all sensor nodes were different microcontrollers with the various sensors as we have discussed. All the micro in the agricultural field here there was one. Where is the mouse? The mouse cursor is visible to all, no? Let us say here one sensor node is having one microcontroller and all those three sensors, temperature, this BME, and the soil moisture sensor. Another microcontroller with again those three sensors. Again another microcontroller with three sensors. All the microcontrollers are having LoRa module and they are transmitting to this server, this gateway. So this client is that gateway which then gets connected to the server and it publishes on MQTT broker. Broker we will discuss just in a few minutes. It publishes, that means it sends the data. Publish means sending the data, and then MQTT broker is an open, like broker means you understand the name broker. It is the connecting the common point. So anybody can, whosoever subscribe to that broker, this broker will publish the data to all those clients whosoever has subscribed. There can be millions of clients. So this can be one display unit in which we have given the subscription protocol, the address, IP address of this broker, and then on this display unit the data is being published in real time. This can be one web application, there can be another mobile application. All can subscribe to the data and get that data which this gateway is publishing. Okay, so there can be another client which subscribe to this broker, and then when data is published to this client, it acts as a server in some computer, in some at some base station, and it's record all the data and transmit that, like display the data graphically and uh, do other data processing algorithm on that data, so that the data is continuously stored also. Okay. So a broker MQTT component having major component is a broker, which is the connecting link, which is the server that handles the data transmission between the clients. It is a topic by the name, like we will decide some name, like we can decide agriculture. If that topic name is agriculture, in that agriculture name the client can publish any data which is coming from the agricultural node, and whichever client, maybe mobile or laptop or any other display device or any other computer, has subscribed to the topic named agriculture, they will get all the data which is published in the topic name agriculture, which is the place a device want to put or retrieve a message from. The message is actually the data which the device receive when subscribing from a topic, or which a device send when publishing to a topic. On in that specific topic, whenever we are publishing something, then we are sending the data. That data is called the message. Publish is the process a device does to send its message to the broker. Subscribe where the device to retrieve a message from the broker. Okay. So number of devices connected to MQTT broker. The number of connected devices clients to the broker depend on the broker service provider. In fact, it can reach a massive number of clients. Those are publishing and subscribing all the time. But the amazing part of this isn't only the huge number of these connected devices, but also the fact that any devices can get any other device's data at any time. As a result, the uh, application based on these quick shared data are limitless. This means there can be various different devices that may be publishing the data by the name, different name of topics, and there can be various other devices which can get subscribed to that data from various different topics. So our complete system uh, is working something like this. So there are different node modules, various different sensor nodes. They are using LoRaWAN communication. Therefore, we have used RF antennas. So low power RF communication through LoRaWAN to the internet enabled gateway, which is acting as a client for the MQTT broker. So it receives through this RF antenna the signal, the data from all the node modules, and then it collects all the data, put it in some specific format, which we have used. The format we used was JSON format. And this is also very common a type of format. So then we send the data to broker, and then at the user end we have used that data in various different forms for mobile application, for storing that data and displaying that data in various graphical forms, and doing the data analysis also. So MQTT, this is another detail of MQTT, using this protocol in various different ways, but we will not go into details of this. This is quality of service, like uh, based on this selection of QoS, quality of service 0, 1, and 2. The encryption of data and the reliability that data will surely reach will increase, but there are like somewhat more details into this. We do not need to go into this right now. If you use MQTT protocol, you will automatically get to know about this. So then this was our this was not our software which we have finally made. These were the type of, there are various MQTT client software which are freely available. This is for the laptop or for the like web interface. This is the mobile interface. So just you need to input the broker, like you can say a broker's IP address, and then you need to subscribe like to some topic, and then you will start getting the complete data that any sensor node is sending to your device. So this was actually our device. This is uh, the sensor node which is used in the agricultural field. This wire, otherwise this is completely wireless. This wire is for the uh, that solar panel. See this at the back side, some solar panel is placed. So uh, based on wherever uh, from wherever side the sun is coming at that particular location, we place the solar panel somewhere nearby to so as to practically use this device for like continuously endless time. Okay, so specification of device: LoRa enabled agri sensing node to measure microclimatic conditions, soil moisture and temperature. Some of the features of the system is, one second, system is auto configurable. If any new node is added in the same agricultural field, it will automatically be assigned a new ID, and its sampling frequency will be set up by the gateway. This means there is one central gateway device placed in the agricultural field. If any such agri sensing node is added, Like you bring some actual node and place it somewhere here in the field and then turn it on. So it will automatically be communicating with the gateway, and it will be assigned a new ID, and sampling frequency will also be set up by the gateway. There is first of its type error logging and automated troubleshooting system, thereby enabling the developers to remotely check the reason for any malfunction, and in some of the cases the error can be resolved remotely. Like there are various different errors which we have logged in the system. uh, some are related to hardware, some are related to software, some are related to battery. If let us say battery goes off, then finally just when battery is getting low, the battery percentage will be transmitted to the gateway. Therefore we can, like, there are different, uh, I think there were around 11 different error conditions. Uh, Reading those type of error condition, we can clearly get an idea of what can be a problem. If there is some problem in the device, in the hardware, is it a software problem, is it a hardware problem, can it be troubleshooted remotely? So accordingly we can give a we can give a help assistance to the farmer who is using this device, sitting in our office only remotely. In many of the cases we can again help the farmer remotely as per the error only to restart its application. Okay. So in some of the typical hardware failure, then we may have to visit the field and repair this device. Otherwise we can, due to this first of its kind error logging and troubleshooting system, we it helps us to uh, uh, find out the various type of faults in the design. Okay, so this much is from my side today in the design of